Hello all, this is HomoMongo Project Part 2, Data Authentication and Security. Our client API transmits the geolocalized object in form of JSON data using two possible protection methods, authentication or SSL client-server connection. When the data arrive at our Dockerized server applications containing MQTT and Node-RED, it is then encrypted using homomorphic encryption and then sent to our IoT cloud storage. Data authentication using username and password. The security issue for our MQTT broker connecting to Owntracks using authentication is that our authorization credentials are transmitted plainly inside that an attacker could sniff the network traffic, read the username and password, and impersonate an authorized client. The recommendation is that it is not good enough for our IoT client-server communications. However, it is an authentication procedure which is better than not trying to protect your data transmission at all. Securing data transmission via TLS SSL. We use OpenSSL to create certificates and keys, then use them to create an encrypted connection between the MQTT broker and the client. Client requirements. A certificate authority certificate of the CA that has signed the server certificate on the Mosquitto broker. We'll create that. And then the broker requirements. CA certificate of the CA that has signed the server certificate on the Mosquitto broker. Also, CA certificated server certificate. And the third one is server private key for decryption. This is an overview of how to generate a self-signed certificate for your project. Overview of certificate authority installation steps. Step 1. Create a CA key pair using this command. 2. Create CA certificate and use the CA key from step 1. Step 3. Create a broker key pair, but don't necessarily protect it. This is the command. Step 4. Create a broker certificate request using key from step 3. Step 5. Use the CA certificate to sign the broker certificate request from step 4. Now we should have a CA key file, a CA certificate file, a broker key file, and a broker certificate file. Step 7. Place all files in a directory on the broker, e.g. certificates folder. Step 8. Copy the CA certificate file to the client. Step 9. Edit the Mosquitto configuration file to use the files. Step 10. Edit the client script to use TLS and the CA certificate. Copy the CA certificate file to the client, which is your Owntracks. We need only this trusted CA certificate on the client, that is our Owntracks. We do not need to create and add client certificate and the key. Note, only the domain host name is very important while filling the server certificate form generated at step 4. Procedure used for public server signed certificate is still similar, but it's still the same procedure. So I follow this procedure to connect them via testmosquitto.org. 1. Generate a private key. 2. Generate the CSR. 3. You should paste the content of the client CSR file into the form of test mosquitto at this URL. testmosquitto.org at this URL, and then get a CRT file. Download the mosquitto.org.crt file from Test Mosquitto. Make sure to keep all files in the same folder in step 5, which is what we need is just these 3 files: client.crt, client.key, and mosquitto.org.crt. Step 6. Use the following command to execute publish. This is to execute publish. Use the following command to subscribe to the Mosquitto broker. Invariably, as can be seen above, both the subscribing client and the publishing client must use the same 3 files in order to negotiate a handshake via test.mosquitto.org, which worked for me. Having installed certificate, I want to open my Node-RED now and start the design of my flow. The first thing I add to the node is the debug button, and then I want to add the MQTT node, and then we'll use it to subscribe. I name the flow HomoMongo. Done. I name the MQTT subscribe. I name this debug. Okay. Next, I want to be sure that my Owntracks is configured to use authentication. So I'm going to start to configure this along with my Owntracks simultaneously. So I take my tablet to start the configuration. So I go here. This is okay. I'm not enabling SSL security. I got to type in my username and password, Dennis. Updated. Okay, done. Beautiful. Okay, the next thing to do now is to deploy. Beautiful. It's receiving from Owntracks. Let me clear this screen and publish from my tablet. Publish waypoint. Good. It's publishing. Can you see the Geofence 400 meters, latitude 38, Unimi resident. Good. Good. Connected. So in this case, I subscribe from Owntracks through MQTT Eclipse.org using authentication, username and password. Although this is not a secure way of transmitting the data, but it's better than not using your username and password. See, username and password. It is better to use this than leave your phone completely not configured. It's not safe that way. Thank you. The next thing I want to do now is to install certificate on my tablet with Owntracks and make it to communicate with MQTT. So I start now. The first thing I do, I come to my email where I send the certificate to ca.crt here and downloaded it. And after downloading it, I go to settings on my Android mobile phone, and then I went to security. I went to install, where I can install the certificate I created. Okay, I'm installing it now. I type in my password to start the process. It has installed now. So I go to Trusted Credentials, checking for Trusted Credentials, to user, where my certificate is stored. Okay, this is it. Look at it. Good. Okay. Now I go to Owntracks. My aim is to enable TLS for the certificate to work. I'm enabling TLS. The certificate is already installed on my mobile phone to use this. Now I change it to 8883, the port setting, 8883. Good to go. Now, having installed certificate on my mobile phone for the Owntracks, I will come to MQTT sub and configure it also. I come here, I have to change to port 8883. This is for TLS transmission. Then I go to security. Well, this is for the Owntracks. It doesn't really matter. Okay, I have to enable SSL for the certificate to work. Here I have set the path to the certificate, server.crt. For the private key, I set it to server.key, and then to CA certificate, I set it to ca.crt. As you can see the path, here is my Mosquitto folder in my computer. Good to go. Update. Done. I now deploy. Beautiful. It's working. I have to clear the debug screen. Publish waypoint. Publish waypoint. Beautifully, it's working. Okay. Now my Owntrack is running the certificate and is communicating perfectly with MQTT using certificate. So my payload is transmitted through the internet and is secure. Even a hacker hacks it, may not be able to decrypt the information. So that is good for security. Summary for part 2. The basic key points covered in part 2 were data authentication via username and password, securing the data transmission via TLS SSL. The following IoT resources were installed: certificate authority, and finally, for part 2, the connections to authenticate and transmit the payload from the client to the server was tested successfully on our Node-RED. Challenges: howbeit The difficulties experienced during part 2 of this project is the increased complexity, and it took me 3 weeks to make the client Owntracks to communicate with my server apps, MQTT and Node-RED. The internet firewall in the university resident also did not help matters at all. Thanks.